Hello, everybody, and welcome to week 13 of Math 1220 online. I hope the exam went well for everybody last week. Your grade should be available within 1 to 2 weeks. Again, just takes a little while before I'm able to collect all the exams from the exam center before they're all in one place. So I appreciate your patience with that, and I will, just like last time, I'll send out an announcement with more information as soon as the grades are posted about the curve and so on. Okay, but anyway, with exam 2 out of the way, we now have just 3 assignments left and then the final exam. So this week we're back to our normal schedule of assignments with web work and RIN due on Friday. And our office hours are also back on their normal schedules, so on Thursdays. Good, so let me point out though, the final exam is at the end of this month, so it can be taken anytime during finals week. Finals week starts on Thursday, April 27th and ends on Wednesday, May 3rd, so it's like a slant week. But anyway, if you want to find a time that fits well with your other final schedules, if you want to make sure you get with your other finals, if you want to make sure you get that scheduled in a time that works for you, do schedule that sooner rather than later. So the scheduling is already open. Okay. Good. So just a brief word about what we're doing mathematically the rest of this semester. It's a little bit of a hodgepodge, actually. So we have 3 assignments left, and each of them is sort of its own thing. It doesn't sort of build as much. So this week, we're basically finishing up what we said started before exam 1. So before exam 1, we'd spent a couple weeks talking about power series, convergence of power series, like how you sort of express functions in terms of power series. This week, we're really going to cap that off with the theory of Taylor and Maclaurin series. So this is sections 9.8 and 9.9 in your textbook. And basically, the idea here is we're going to describe how to use calculus to find a power series for any function. So any function that you know how to compute the derivatives of, you'll be able to find a power series that represents it, at least in sort of good circumstances. Or if you can't find a power series, you'll at least find a polynomial that approximates it. Sort of generalizing the way like a tangent line approximates a function or the graph of a function, you'll sort of have higher degree polynomials, or the graphs of higher degree polynomials that approximate a function near a point. So that's what we're focusing on this week. Then in week 14, so next week we'll shift gears, and we're covering sections 10.1 to 10.4 in the textbook, which are on conics. So conics is just a fancy word for ellipses, parabolas, and hyperbolas. And so these are sort of some basic important shapes that show up a lot in mathematics and physics and other areas. And so we're just spending a week sort of studying how to like write down the equations for these, how to understand some of their properties, how to recognize equations for these, how to think about their graphs, and so on. So this is a little bit of a departure from the calculus we've been doing most of the semester, but somehow it'll connect at least a little bit through various sort of calculus computations. But this is really about sort of recognizing these shapes and sort of understanding the equations and properties of these shapes. And then finally, in week 15, we shift gears a little bit, and we're going to talk about polar coordinates. So that's sections 10.5 to 10.7 in the textbook. And this is basically the idea is like instead of identifying a point in the plane with its x and y coordinates, you instead identify that point by saying what angle you sort of rotate to off of the x-axis, so an angle theta, and then how far you go from the origin. So you sort of rotate some distance off the x-axis, and then you go some distance in that direction, and so that takes you to some point. And you can use that angle theta and that distance r instead of x, y coordinates to identify a point in the plane. And you can ask sort of how graphing functions works in this setup. So if you have r as a function of theta, what do graphs look like? What kind of cool graphs you can draw that way? What kind of cool shapes you can get that way? And then how you do calculus using those coordinates instead of x and y coordinates. So that's sort of what we're going to cap off the semester with. This stuff plays a big role in Calculus 3 if you go on and take that. So when you start doing sort of volume computations for sort of shapes that are sort of rotated if you sort of start with some shape in the XY plane and you sort of rotate it around to cut out some solid, and you want to compute the volume of that. So polar coordinates play a pretty big role there. So if you keep on going in calculus, you'll come up against them quite a bit. But for us, it's just sort of a fun. It'll feel sort of separate from what we've done so far, except for like when we go back and understand how to do some calculus computations in those coordinates. But it's setting us up for something in the next semester. Okay, well, again, I hope the exam went well, and I hope I'll see you all or hear from you either in my office hours or via email if you have any questions. And have a nice week.